If nulls are so evil, why do we use them? There are several common use cases. We already alluded to one. They provide a default for reference types. Without null, what would we use as a default? For strings, it could be an empty string, but for object reference variables, would it default to an empty object? If so, and some of the properties were required, our empty object would be invalid, so we'd have more ways things could go wrong. Another common use case for nulls is for specifying that a property has not yet been set by the user. Looking at this user interface, the user may not have set the effective date. When the user confirms the price change and we save the user's entries in a data store, such as a database, we don't want to store the date's default of 110001. Rather, we want to store a null, clearly defining that the value has not been set. So nulls are useful for knowing the difference between not yet set and a value type's default value. But how do we assign a null to a value type, such as the state? That's the purpose of nullable value types. Here are value types. We can't assign a null to any of these. We can only assign a value of the appropriate type. But we can instead define these variables as nullable value types. We specify a nullable value type by adding a question mark after the type declaration. Nullable value type variables default to null, and we can assign a value or a null. For example, is in stock can be true, false, or null. Price can be a decimal value or null. Effective date can be a date or null. You get the idea. Using nullable types, we can evaluate whether a property is not yet set and is null, or whether the property was set to a specific value. But haven't we just made things worse by introducing more nulls? Let's walk through how to defend our code from nulls in these nullable value types.